when I hit the play button, this is what we have. So I can shoot here and create a portal, and I can shoot here and create a portal, and I can pass through these portals. There you go. I can also go here at the top and shoot over here. So let me just shoot somewhere down, a little bit more down, and over here, the next one. And I can shoot with the left and the right mouse button. So if I pass through this portal, I'm now here at the top, and you get the point. So yeah, basically this is it, and we will create this using C++ and Unreal Engine. And by the way, this is not for beginners. So if you are, a complete beginner, make sure that you go through my C++ lectures here on YouTube or in my academy. And if you want to learn more advanced stuff, make sure that you do that in the academy. Link is down below. Hit the like, subscribe, and all of that stuff, and let's get into this tutorial. Alrighty then, my game dev gangsteronios. Now that we saw the effect that we are going to create, let us jump and create that effect. Now below this video, you will see a link to download a file, and inside of that file, which is a zip file, you will see a folder. Inside of that folder, you will see a starter project, a completed and finished project, and you will also see text for the scripts that we are going to create. Now, you are going to open the starter project, which is this one that you see right here. So what we are going to do with this starter project is, first things first, go here into the C++ classes and portal, and here I'm going to right click and create a new C++ class. Now from here, I'm going to inherit the object. So click here, show all classes, and click here on the object, because this is the dude that we want to inherit. And then click on next, and we want to create here our math library. So let's go here and hit the create class. Of course, let me just lower my volume a little bit so that we, don't die waiting until it compiles and, kills our ears when it finishes and all of that stuff. So while we are waiting for this to finish, I'm going to sing to you as usual, and that costs extra. So yeah, PayPal me another $500. Well, I'm going to cut out here. Wait until this. Wait. I have so much fun creating these videos. Wait until this finishes, and then I will get back to you. And yeah. And so after a few painful moments, here we are once again. So I have created my math library. Now what you're going to do is, in the folder that I just told you to download, where you have the starter project, you will also see these math library.h and .cpp. So what you're going to do is take and copy everything from the .h file, and then go here inside of the math library.h and paste it. Simple as that. And then you're going to do the same thing with the .cpp, but this time you're going to paste everything here inside of the .cpp file. And basically there you go. So now we can start and code all of the functions that we have here, because if I go back here, what we have is, as you can see, U function, blueprint callable, converter, convert location, convert rotation, because we're going to use these functionalities to convert the location of our character, so from one portal to another portal, so that we can simply, how can I say, transport or portal our character from one portal to another. So if we have a portal here and a portal here, character goes here, then we want to transform him over here, and vice versa. You get the point. So let me just do this again. Let's go here in the math library. First things first, we are going to do this with the convert location. So for the convert location, we're going to say here f vector direction. So the first thing that we are going to calculate is the direction, which is going to be equal to the location that is passed over here, and subtract from it the portal location. So portal location. So here, get actor location. There you go. So we have the direction is equal to location that we pass here minus the location of the portal. Next, I'm going to say here f vector, and that is going to be equal to, or actually first we're going to call it target location, which is going to be equal to now target get actor location. And by the way, we talked about this a lot when it comes to the direction and how we can calculate the direction. If you're watching this on YouTube or part of this tutorial on YouTube, then you can find out more about how to calculate direction in my Game Development Academy. If you're watching this in the Academy, then you went probably through some of these. In order to find the direction from one place to another, you simply subtract one from another, and you will get that location. So next over here, I'm going to say vector dots, and next what I'm going to do is I'm going to say here dots dot y, that's going to be equal to f vector. So it's f vector colon colon dot product, and from here I'm going to pass the dot product between the direction and the portal, and from here get actor forward vector. There you go. So this is for the y. Next we have here dots dot, actually this is for the x, excuse me. So this is for the x, and now for the y we have the dot product. So I'm simply going to copy this so that we don't have to, you know, type it out. So direction and get actor, but here we're going to say right vector. So right vector. And last but not least, I'm going to copy this and paste it over here. And this one is for the z. So we're going to have here f vector dot product direction and portal, but this time it's not going to be get actor right. Instead, it's going to be get actor up. If you don't know what is a dot product, in short, a dot product between two vectors returns a float value which determines if the object whose first location, so basically if this object here, so the first pass parameter, is facing the second one, which is this one over here. So depending on the value, and that value is going to be between 0 and 1, the closer it is to 1, then this right here, this value here, this location here is facing this one over here. If it's equal to 1, basically it's practically just facing this direction. Now, if you want to learn in more detail about this, I use it a lot in my Game Development Academy. So moving forward, now that we have here the dots for the x, y, and z, I am going to say here f vector, and this one is going to be new direction, which is going to be equal to dots x, and I'm going to multiply that with the negative of the target, and here I'm going to say get actor forward vector, plus then I'm going to say here dots y, and from here I'm going to multiply that with the negative of the target, and from here I'm going to say get actor right vector, and then I'm going to say plus and then dots dot z, and from here I'm going to multiply that with the target get actor up vector. This is because we are changing the directions. And because we are changing the directions, we need to multiply with the negative of the target's forward and right vector, which means when we teleport our player from here to here, that means we will set his forward to the negative of the target. And currently, if as you can see over here, let me just explain like this, it will be more clear. So here we have our player, or this is one portal, and this is another portal. And our player enters the portal like this. So as you can see with this arrow, this direction is the forward direction the player is facing. So when I teleport him here, he will be teleported here and he will face this direction, as you can see over here. So this is the direction he will face. But because we are multiplying that over here with the negative of the forward and over here negative of the right, that means when we teleport our player who is entering from here, so he is facing this direction, when we teleport him over here, he will be facing like this. So this is going to be his direction that he's going to face because we have multiplied that with the negative of the forward. So if the forward is here and we multiply with the negative, that means it's going to look in the opposite direction. So this is essentially what we are doing. And over here, last but not least, what we're going to do is we're going to say return the target location plus the new direction. So the target location is actually the location where we are going to teleport our target. And as you can see, it's at the target's location, which is what I was talking about. So it's this one right here and this one right here. This is the target location. So we are going to teleport him from here to here. And then we are going to do these calculations over here so that we can make him face the correct direction. So this is when it comes to the converting the location. When it comes over here to the converting rotation, we are going to say f vector, and from here rotation adjustment, and that's going to be 0.0 and then 0.0 and then minus 180, which is also going to contribute to the direction where the character or our actor, player actor, is going to face. So over here, F vector, and then there's going to be local adjustment, and that's going to be equal to F vector, colon, colon, 0 vector is in the initial value. Next, I'm going to say here if R vector, so it's F vector, colon, colon, dot product. And from here, I'm going to use the portal, and then from here, get actor forward vector. And I am also going to get the dot product between the forward vector and the F vector, colon, colon, up vector. And then I'm going to test if those values are greater than a kinda small number. And what the hell is this kinda small number? What is this, teacher? Are you joking with? No, I'm not joking. So basically, if you want to determine if two floats are approximately equal, so approximately, because you can never determine a float 100%. That's how float values work in any programming languages. But yeah, still, if we do something like if 1.1 is equal to 1.1, that's going to return true. That's everything is fine. But still, it uses this kind of small number behind the scenes. So basically, you need a standard way to say, okay, this is close enough. So this is what we are saying here. And so this is a standard way of saying, okay, yes, the difference between these numbers is small enough to consider them equal. And the reason this exists is because floats are, as I said, not 100% accurate. That's the only reason why. So this is a standard way to say, okay, these floats are approximately small or close to each other that we can consider them they're equal. So what's going to happen after that, I'm going to say here local adjustment dot x. That's going to be equal to f math. From here, I'm going to say unwind degrees, and then I'm going to pass here portal, and from here get the transform, get the rotation dot Euler dot x. What is this going to do? Well, this will basically make the unwind degrees, you see, utility to ensure angle is between plus minus 180 degrees. So we're essentially making sure that the angle is between plus or minus 180 degrees. That is what we are doing. So next we are going to say here local adjustment dot y is going to be equal to 180 degrees, or 180 for the value, and rotation adjustment, so rotation, did I call it rotation adjustment over here? Let me just see. Yeah, this is the rotation adjustment, but for whatever reason, it's not giving me the autocomplete. So rotation adjustment dot z is going to be plus equals the local adjustment dot x. Now over here below, we're going to say else if our f vector colon colon dot product between the portal and get actor forward vector, and then the f vector up vector, if that is less than the negative of kinda small number, and I'm simply going to copy this so that I don't have to suffer. So essentially over here, we're testing if this value is greater than the kind of small number. But over here, and we need to add open close parentheses, we're testing if the same dot product between the forward vector of the portal and the up vector is less than or equal to the kind of small number. Then what I'm going to do is copy all of this, paste it here. So we are going to have the local adjustment x to unwind the, so unwind or unwind, however you want to call this, degrees, portal, transform, get rotation, Euler, x, everything is okay, but over here we're going to set it to minus 180, and from here the z is going to be minus equals local adjustment dot x. So next what I'm going to do here is go and I'm going to say f quad, and then I'm going to say quad rotation is going to be equal to f quad colon colon make from Euler, and over here we're going to say rotation adjustment, and we're going to multiply that with f quad, so it's f quad rotation. There you go. Now what is this F quad? Teacher, you are trying to kill me. No, I'm not. I am trying to help you become a pro game developer. So this F quad basically is a floating point quaternion that represents a rotation about an axis. So a rotation around a single axis. In our case, we want to rotate our character in the Z or on the Z axis, because the Z axis represents, you know, if we rotate left and right, basically. And this is how we are going to do that, by using an F quad, which will represent a rotation around that axis in a 3D space. So next over here, we're going to say F quad, and I'm going to call this one local quad. That's going to be equal to quad, and it's quad over here, make from Euler. So it's make from Euler, and passing here local adjustment. And then we're going to multiply the local adjustment with the portal and get the actor transform and get rotation. So get rotation dot inverse, and then multiply that with the quad rotation. There you go. Now, what the hell is the inverse over here? So what is this here? Well, inverse, basically, it transforms a rotation by the inverse of the supplied transform. For example, if our portal was an object's transform, so this is its transform, this will transform, so this is going to transform its rotation from world space to local space. What does that mean? Local space is relative to itself, so this is the character and his local space is the space around him relative to him. World space is relative to the world, so to the whole world in the game, that is the world space, but the local space is only relative to the actor himself. So the last step over here is that we need to say F quad new world quad, and that's going to be equal to target, and from here we are going to say get actor transform, and then get rotation, and multiply that with the local quad. There you go. And last but not least, we need to simply return here the new world quad dot rotator, and this is what we are returning with the convert rotation. So this is how we're going to convert the rotation between the target and between the basically between the actor who goes inside of one portal and exits outside of the other portal, and we will see this. Over here, to check is in front, we are going to create an F-plane, which is an imaginary plane at the location and direction. So portal plane, which is going to be equal to F plane, and from here portal location, portal normal. So again, as I said, this is going to create an imaginary plane at the location in the direction. So imagine this is our character and we call this to create it at our location. So it's going to create this plane depending on the direction. Normal is basically it normalizes the direction. So it doesn't care about the length, it just cares about the direction. So it can be forward, it can be backwards, it can be left and right. You get the point, but it's going to create an imaginary plane. So over here, we're going to return portal plane, and from here plane dot, and then we are going to pass the point over here, and if it's greater than or equal to 0. So basically our plane dot, as you can see over here, calculates the distance between the plane and the joint. So it will calculate the distance between the plane and this point. If that distance is greater or equal to 0, it will return true. If it's not greater or equal to 0, meaning it's less, it will return false. And that will be it. Over here in our check is crossing. So we are going to check if the player is crossing with the portal. So over here, I'm going to say F plane, and I'm going to say portal plane. It's going to be equal to F plane and portal location, and then passing here portal normal. You know, I have issues, you know, portal, so you cannot pronounce it every single time, okay? Don't judge me. Anyways, over here, F vector, intersection point. Next, what we are going to do here is we're going to say Boolean is intersecting. That's going to be equal to F mat : segment plane intersection, and passing here out last in front, or actually last position, endpoint, and then over here portal plane, and then intersection point. So this segment, plane, and intersection, it will return true if there is an intersection between the segment specified by the starting point, which is this one over here. So if there is, a segment, so intersection between the starting point and the end point, which is this one over here, and the plane on which the polygon lies, which is the portal plane. So basically, if these two positions or locations intersect with each other on this plane, then this will return true. And of course, it will return the intersection point in this variable. So it will return exactly the point where they are intersecting. So let's imagine this portal plane is here, and this location is here, and this location is here. So they are intersecting. The intersection point is going to be right here. And of course, this is going to return true. So now that we have that, we are going to say over here, bool is in front, which is going to be equal to check is in front, which is this one over here that we have just calculated. So is that intersection in front or behind? And that means if the character is intersecting with the portal forwards or backwards. So over here, check is in front. So over here, I'm going to say point and portal location, and over here, portal normal. So now I'm going to say here, boolean is crossing is by default equal to false. And over here, I'm going to test if is intersecting, and we are not in front. So is in front. There you go. So front. And from here out, last in front. There you go. So if all of this is true, then we're going to say is crossing. So is crossing over here is equal to true. So if we are intersecting and we're not intersecting in front, and we have the last out, so last in front, then this is going to be equal to true. If that is the case, over here I'm going to say out, last in front is going to be equal to is in front, like that, and out last position is equal to the point, and we are going to return this return that is crossing. So this is essentially, and let me quickly go here and compile everything. Just lower the volume so that we don't torture our ears for whatever reason. There you go, compile, saved. And this is the base class that we are going to use for calculations such as I said, making sure that we can teleport the player between portals, and also placing the portals on different surfaces, because we will not be able to place the portals on different surfaces, especially if the portal, for example, if the portal is this large and we try to fit it on a wall that's this large. So that's not going to happen, and we're going to use the MathAv library to calculate all of those things. Anyways, that will be it. Something's not clear, make sure that you ask, and I will see you guys in the next video. Alright then, my game dev gangsteronios. Moving forward over here inside of our C++ classes and portal, we're going to right click and create a new C++ class. First things first, I'm going to inherit from the actor. So select the actor, click on next, and this one is going to be our portal pass. And then we're going to click here, create, and create the portal pass class, which is basically going to represent our portal. And hopefully now it will take less time. Let me just lower the volume a little bit so that we don't hear when that compile sound goes. There you go. And right click again, new C++ class, again inherit from the actor, go here, click on next, and this one is going to be our portal manager, and then go here and create the class. So of course we need to wait, all of that stuff. I'm going to that's $100 more than what you paid for the class, because I have just sang to you, I'm a famous singer. So right click one more time and go here, and this time we want the player controller. So player controller, there you go. So select the player controller over here, click on next, and this bad boy is going to be our portal player controller. So controller, make sure that you spell that correct, and click here create class so that we can create a class and start doing our thing, basically. What else can I say? So let's wait for it to finish, and then we're going to jump into the Visual Studio and start some magic coding and all of that stuff. So let's go here, reload, there you go. So we have the player controller, portal manager, portal pass. We don't need the math library, so I'm going to turn it off. Now the next step to do is to copy the code from the folder that you have, starting with the portal pass. So make sure that you copy everything from portalpass.h and paste it over here. Then do the same thing with the .cpp file. So let's go copy and go here in the portal pass cpp and then copy everything. Of course, we will code all of this, don't worry about that, but at the moment we're just preparing everything. So next we have the portal manager.h, and let's go here, portal manager.h, copy and paste. Let's go into the cpp of the portal manager, there you go. Portal manager cpp, voila, everything is defined. And next we have the portal player controller, so copy everything. Let's go here, portal player controller, and then one more time for the .h, and let's go here and do the same thing, and voila, there you go. Moving forward, we are going to code our player controller. Now, if we go here, there's not that much happening here in the player control. So we have the portal manager that we're going to return and all of that stuff. So essentially over here in the begin play of our portal player controller, I'm simply going to say portal manager. That's going to be equal to get world. So world like that. And from here, I'm going to spawn the actor, and the actor that I'm going to spawn is going to be a portal manager. Like that, and I'm going to say here a portal manager static class like that, and open close parentheses, and then from here I'm going to say f vector 0 vector and f rotator 0 rotator, so 0 rotator. And that will be it for spawning our portal manager. I'm also going to say here portal manager, and that's going to be our first. Over here I'm going to attach to actor, this referring to the player or the portal player controller, f attachment transform rules snap to target including scale, there you go, portal manager. From here set controller, so set controller pawn this, and from here I'm also going to say portal manager, and from here set portal class, and that's going to be the portal class that we have over here. So essentially, what are we doing? If I go here, if I double click on this and go to definition, over here we are going to set the owning controller to the owner that we pass, and for the portal class we are going to set the class over here to the portal class to the class parameter that we pass in the portal manager, because the portal manager is going to be the one who is responsible for managing the portals, and he will be the one responsible for allowing us to spawn the portals and so on and so forth. And let me just quickly go back here and compile, make sure that everything works okay, so that we can proceed and create a blueprint out of our player controller. There you go, it works. So let's go into content and right click a new folder, and I'm going to call it blueprints, and inside of the blueprints folder I'm going to right click and blueprint class, and from here filter for the portal player controller. There you go, select BP portal player controller. We also need to right click over here and create another blueprint, which is going to be our game mode. So over here, game mode, BP portal game mode. So let's go into the project settings. By the way, I'm going to go quickly here and in the developer, and over here widget reflector and 116, so that I can have, you can see better what's happening over here. So in the maps and modes, I am going to select our BP portal game controller. The default pawn is going to be our first person character, and over here for the portal player controller we are going to have BP portal player controller. Simple as that. Let me just make sure that everything works. Yes, it does. There you go. So yeah, everything is fine. Later on we will also code our player, the third person player, blah blah blah, the first person player shooter that comes with the project. So we will code him so that we can actually shoot portals and not shoot these, you know, weird balls that are bouncing every single time. So yeah, anyways, that will be it. Moving forward in the next video with our preparation, where we are going to code the portal class, and I will see you then. Alrighty then, my game dev gangsteronio, the last step is upon us, and the first thing that we're going to do is go in the project settings and input, and over here for the action mappings, we're going to add one action mappings, which is going to be fire red, and another action mapping, which is going to be fire blue. There you go. For the blue one, we're going to say left mouse. So there you go. For the red one, we're going to say the right mouse. Get the point. There you go. So right mouse. Right for the red, left for the blue. Okay. So the next step is to go inside of the Visual Studio, and we are going to open our portal character.h and .cpp file. In the portal character.h, so at the very bottom, we are going to copy this or these lines of code. So from here, we have the protected fire, on blue fire, on red fire. Fire! I am on fire! So the next step to do is to, of course, code these functionalities. So from here, I'm going to create the functions. So it is going to hopefully have mercy upon me and code it. So come on, Visual Studio, come on. Come on, Visual Studio, come on. There you go. So I'm going to do the same thing for these two as well, and, you know, hope for the best. Again, I have a very powerful computer, and look how much it takes sometimes. Well, I gotta be honest, I, didn't turn it off for like 3 years. Just kidding. But anyways, yeah. So there you go. We have defined all three of these functions, and let's go here in the portal character, and at the top right here, we're going to add these two includes. So include the portal player controller and portal manager. So make sure, as I said, to include portal player controller and portal manager inside of the binding over here. So let me just find here, set up input player binding. First, find this one with the fire. So this one we are going to turn off. So I'm going to simply do it like this and turn it off, and there you go. So make sure that you comment this line of code, and here at the bottom, right below everything else, I'm going to paste these two lines of code, which are going to bind the fire blue with the on blue fire, fire red with the on red fire. So make sure that you do that. And then we're going to go here and code all of our three functions that we have added. For the fire, which is going to be the first one that we are going to code, what we're going to do is we're going to test if we don't have, or if we have the fire sound. If that is not equal to null, then we're going to call the gameplay statics, and from there, not abort inside member function, but we're going to say play sound at location, passing here this, passing the fire sound to play, so fire sound, passing the get actor location. There you go. I'm also going to test here if our fire animation is not equal to null, and this is already pre-built in the character. Don't worry, everything we have that we're testing here. So we're going to say anim instance, which is a pointer. Anim instance, so instance is going to be equal to mesh1p. From it, we're going to get the anim instance. There you go. From there, if the anim instance is not equal to null, then from there anim instance, and we are going to say here montage underscore play, passing our fire animation and passing 1.0, which is going to be the speed or the normal speed by which we are going to call the animation. Here in the on blue fire, we are on fire. I'm going to say a portal, and not portal character, portal player controller. And this one is going to be player controller. It's going to be equal to cast into a portal. So a portal player controller. Passing here get the world. Passing here get first player controller, like that. Next, what I'm going to do is I'm going to test if the player controller is not equal to null PTR. And from here, if it's not equal to null PTR, we're going to say a portal manager. And that's going to be equal to portal manager, or call it portal manager. And we're going to get the portal manager from the player controller, because this is where we actually put the portal manager. So portal player, actually player controller, and from here get portal manager. There you go. And then here, if the portal manager is not equal to null PTR, then we have the portal manager. And what's going to happen if we have the portal manager? Then, well, we are going to say fire first, which is the function that we, created over here. So we are going to fire. After we fire, we're going to say constant f vector start, which is going to be equal to fp muzzle location. If that is not equal to null PTR, there you go, with a question mark. If that is the case, so it's not equal to null pointer, then we're going to say fp muzzle location, and from here get component location. This is going to be the location where we're going to spawn our portal, or actually from where we're going to fire the portal. So over here, muzzle location, and colon over here, get actor location. So get actor location plus the get control rotation dot rotate vector. So control rotation, rotate vector, gun offset. There you go. So this is going to be the start from where we are going to fire. So from here, we're going to say constant f vector end is going to be equal to start plus first person camera component get forward vector, and multiply that with 5,000. So we are going to fire from the start, which is this one that we have just created, towards the end, which is going to be calculated by using the forward vector of the camera, which means in the forward direction, and then multiply that with 5,000. Then we're simply going to call portal manager, and from here we're going to say spawn blue portal, passing here start and the end. There you go. So it's going to use that in order to fire the blue portal. And for the red portal, basically everything is going to be the same. So we're going to copy all the contents from our function over here, paste it here in the red one. And here, instead of spawning the blue portal, we are going to spawn the red portal. And that would be pretty much it. So everything else is going to stay the same. We're going to get the manager. We're going to calculate the muzzle location, or the start location using the muzzle location, and everything that we did so far. Now we can go inside of our editor over here, and first let's make sure that I don't have any oopsies, and let's see, no oopsies, hopefully, no, let me see, and compiling C++, come on, I'm nervous, so there you go, yes. Now also, before we do anything, as you remember when we talked about putting the portals on the surfaces and so on and so forth, so how large the portals currently are, they will not be able to fit on these surfaces. So I'm going to take this one and I'm going to resize the scale like this, take this one, resize the scale a little bit, also for this one as well, resize the scale, do that for this bad boy here as well, take this bad boy as well and resize him, this bad boy as well. So just resize them so that we can, make sure that we actually can fit the portal on any of these surfaces. So when we, shoot and, basically, as I said, we can fit the portal on the surface. So now we can hit the play button, and when I shoot somewhere, we will see a portal. There you go, we have one portal, and when I shoot here, there we have another portal. If I go here now through this one, there you go, look at where I am at this portal. So when I go again over here, now I'm in this portal over here, as you can see. So let me just shoot over there. There you go, there is one portal, and if I shoot here, let me try and see. Look at that, where I am, look at that. So yeah, if I shoot here and go there, there you go, I'm in this portal right there. So yeah, make sure that you fix the mistake that I did in our portal character controller, which is right here, and I added that info inside of that lecture. So make sure that you here return the portal manager, because initially here was return null, and if it's null, then we will not be able to shoot and spawn the portals and yada yada yada. You get the point. Anyways, this was about creating portals, more advanced stuff in Unreal Engine in C++, and yep, that would be pretty much it, and I will see you guys in the next video.